Welcome to qnawire.
In this question, it is given that a raindrop whose radius is 1 millimeter and the mass is 4 milligram is falling over the head of a bald person. And once the raindrop is falling over the head, it is getting splashed over there. So we have to find what is the average force applied by the raindrop on the head during splashing. Okay, so let's note down the data first. The radius of the drop, that is r, let's say it's given as 1 millimeter, which I can convert in meter, so that will be equal to 10 power minus 3 meter. Okay, the mass of the raindrop is 4 milligram, so that if I convert it to kg, so that will be 4 into 10 power minus 6 kg. Okay, now as it is mentioned in the question that during splashing we can assume that the raindrop is traveling a distance equals to the radius of the raindrop, and also uh, after it is completely getting splashed, it is coming to a rest, right? So then we can just assume one thing, that just at the moment of hitting the head, speed of the drop is, let's say, u equals, as it is given, 30 meter per second, and after splashing, the final velocity of the drop, final velocity of the drop, let's say that is v, so that is going to be 0 meter per second, as the drop is finally coming to at rest. Okay, so then we can just assume that during splashing the raindrop is going to be decelerated, and the total distance traveled by the drop during splashing, I can write it as s, that is as given in the question, that will be equal to the radius of the drop, which is equal to 10 power minus 3 meter. So then we can first find the deceleration of the drop. Okay, so to find the deceleration of the drop, we can use the equation of kinematics, v square equal to u square minus 2as. Why I am using minus n? Because the drop is getting decelerated. So from here I can write that a is going to be equal to u square minus v square by 2s. Remember, a represent deceleration. So if I put the values, u value is 30, that square, minus v, that is going to be 0, by 2 into s is 10 power minus 3. So we can write that a, on simplifying this, we will get equals to 4.5 into 10 power 5 meter per second square. So this is the deceleration of the raindrop. Then the force exerted by the drop over the head, or you can write on the head, is F is going to be equal to what? Mass into acceleration. So the mass of the drop is 4 into 10 power minus 6 into acceleration is 4.5 into 10 power 5. On simplifying this, we will get F equals 1.8 Newton. So this is the answer for this question.